So with all these trig functions that we've looked at so far, they all kind of work the same way. We have an angle. We enter that angular angle into our calculator. We ask what the sine, cosine, or tangent is, and it gives us back a number. That number is the ratio of a pair of sides, right? Opposite, adjacent, whatever, depending on the specific trig function that we chose. Well, what if we want to go the other way? Right? What if instead of knowing an angle and wanting this ratio, I have this ratio and I want to get the angle? Well, we can do that. We can do that. And the way we do this is with what's called an inverse function, right? And inverse, kind of think of it as going backwards, right? Where the original function takes an angle and gives you a number, the inverse function takes a number and gives you an angle. Right? Now, the way this is written, I will admit, is a little unfortunate. Inverse functions are usually written with that little -1 up as a superscript, right? For example, the -1 up here, sine negative first, cosine negative first. What makes this unfortunate is that -1 sure looks like an exponent, and it isn't. I want to be really clear about this. If you're familiar with negative exponents, when you see sine negative first x, that does not mean 1 over the sine of x. Right? When you see a -1 up in that position with a function, I want you to think inverse. Okay, so there's another way we write this sometimes. Sometimes we'll write these with this arc prefix, arc sine, arc cosine, and arc tangent. I still do that because it was fairly common when I learned this stuff a while ago. It's becoming less and less common to see it now. It's kind of starting to become almost a little archaic to do it that way. But you will see it from time to time, right? So I put it in here just so you're aware of it. So how can we use these things? Well, let's go back to solving triangles. Right? Remember, solving triangles refers to a situation like we have here, where you're given a triangle with pieces of it filled in, and you want to find the missing dimensions. In this case, that's going to be the two angles and the measure of the hypotenuse. Okay, well, let's think about angle A first. Right, the tangent of A. Remember, tangent is the opposite side's length divided by the adjacent side's length. And for our triangle, that's going to be 7/4. Right. But I want to know what A is. And the way we do this is we say, okay, well, then A is going to be the inverse tangent of 7/4. You go to your calculator, you enter that value, and you should get, again, very long decimal number. I'm going to round it to 3 digits, 3 decimal digits, 60.255 degrees. This is another situation. I mentioned this, I know, in a previous lecture. Be aware of degrees versus radians, right? Be sure you're getting these values in whichever of those two you're trying to do the calculations in. Okay, so now from here, um, you really are kind of home free, right? We could say B is equal to the inverse tangent of 4/7, right? And that would work. Or you could really kind of do it the easy way. I think you could say, remember, all the three angles have to add up to 180 degrees. So 180 minus 90 minus that 60.255 there, that's going to give us 29.745 degrees. Right? Either way is fine. Right? Either way is going to get you the right angle, whichever way you think is simpler. All right, and that leaves C. Well, now you've got options, right? You certainly could do this using the trig methods we did in the last slide. For example, right, I could say not tangent. We're going to do, let's say, the sine of A. Remember, the sine is the opposite over the hypotenuse. And for that angle, that's going to be, I'll make sure I get them right, that's going to be 7 over C. We know what A is, right? We calculated it up here. You can put that angle in for A and solve that equation. Absolutely, that'll work. Or, since this is a right triangle, we could also fall back on our old friend Pythagorean theorem and say this is 4 squared plus 7 squared equals c squared. Let's see, that's 16 plus 49. So this is c squared equals 65. You take the square root of both sides, and we get that last value that we needed, 8.062. That'll be the value of c. Inches, right? There were units in the question. So let's go ahead and throw inches in there as well. All right, so that's inverse trig functions, right? That's how we can find angles using our new trigonometry techniques. So in the next lecture, we're going to take a look at some practical applications of this. We're going to talk about things like angle of depression and angle of elevation and see how we can use those combined with these trig functions to answer some practical questions.